Hello, welcome back to the stream. Let's check our homepage. Okay, looking correct. So today we're gonna do something a little bit different. We're gonna try to write the JS, JavaScript or TypeScript interpreter for the Core 2022 game because we actually need an interpreter to do anything useful in terms of machine learning or anything like that. So that is gonna be super important. Let's switch to our own channel. So, and this interpreter is not gonna be like a pure TSJS interpreter because there's still quite a few features missing on the TS side. So I'm gonna leverage the kaggle-environments CLI and then build top on top of it in Node.js to build our own, kind of interpreter, but we'll leave the underlying running of the simulation to this interpreter itself. I've also been studying this replay JSON, and I think it has all the information that we need for a complete game. So it's very, very long. You can see here it's like 50 lines of 50k lines of JSON. But I think we're gonna cheat a little bit here for the training process because we're just gonna take the reward for the end of each game as our agent's reward, right? So it's just gonna execute the same policy within each game, and then just gonna keep execute, and then we treat like each game as one iteration, so to speak, for our training process because I think it's quite hard to interact with the CLI step by step. So I think to begin our interpreter process, we would just take the final reward, which is this one, nicely computed for us, as the reward for one iteration, right? So within one iteration, we just pass the same policy to the agent, and agent will use that same policy to complete an entire game and then obtain a reward, and then that's when one iteration ends, and then we get that reward. So it's not gonna be turn by turn. It's gonna be actually 400 turns in one shot, and then we get a reward. I'm not too sure if it's gonna make the model take the model much longer to train or make it less effective, but I think it should still work to a certain extent. We'll try it out eventually with some machine learning. But for now, we're focusing on the interpreter itself. So the interpreter is gonna do a few things. It's gonna fire up the kaggle-environment CLI with the agent that we want to run, and then it's gonna process the output reward, just like we did here for the compile. And then we're just gonna, like, we're just gonna do some modification maybe to, and see whether we can improve it, right? So we're just gonna train it at once. We're gonna treat it as one step. Yeah, I'm quite excited to see how it works out. So let's take a look at the out first. Thing. So this one has a out, right? And a normal play also has a out. Yeah, I think this out is the HTML one, so you want the JSON one. So yeah, let's start by writing a interpreter file, I think. What shall we call it? Interpreter.ts, I guess. That's fine. display interpreter TS. And let's actually run it as a sub-process. Node.js spawn process. Okay. Let's just copy this, and then we're gonna spawn it. Okay, let's save this replay file first. It's taking quite a long time to save it. I think we don't actually need to worry about the replay file for now. Let's see. I think we're gonna use like a combination of these two. And then we're also gonna take this. I think we need the out to be like this. Yeah, so that it can output the JSON file that we need, right? Okay, let's change this up a little bit. Arguments. Go to run environments, core fleets, agents, and we'll let agents equals to is 4. Right? So this is just an example of how it works. So we're passing the agents here. Oops. And then we pass the log. Okay, it actually out-completes for us. That's very interesting. It's very, very smart. It's very, very smart. Let's say replay name, right? Let agent equals to main. And then this one is gonna be agent, right? And then we'll output the file path to reflect that it's the agent. Now we'll run this for a few evaluations. Let's say function run agent iterations number agent string, and then for I iterations. If it's 10, then it's 0. Okay, so it starts from 0. Let's put this here. Agent So agent is just this arguments underscore. Okay, it's not quite smart enough to figure out what to put here, but it's okay. So this one, I think the Copilot should be able to figure out, right? Yeah, pretty sure it's. Oh wait, I can't use arguments, right? That's the reserved keywords. So let's name this as Python arguments. Let's not, shoot ourselves in the foot with the reserved parameters. Yeah, and then it's gonna read the replay JSON, right? So let's actually read that. Let's take this file. Process the result of a file name, which takes in a string. Okay, you need the fs, sure. Plus file name. Okay, this is an evaluation thing, but I think it's fine, right? I think it's fine. Yeah, it is, even though it's an evaluation thing, I think it's still fine. We'll just reuse this. Okay, I'm passing the agent as well. Maybe name. Never mind, I think agent is better. Agent. No, I don't need this. Cache E. Console.error. Okay, pad. Okay, we don't have pad function. Okay, and then we're gonna process result. Agent replay. Okay. Let's actually name a variable const file name. No, I don't like that. I like this one. File name, and then this one is also going to take file name. Out.log. Okay, so this one is gonna be result file name. Then we also have a log file name, which is just gonna be log dot. I feel like we have too many log files already. Okay, I think I just call it out something. Right, so that we don't get confused with other things. Let's move all these log files to somewhere safe. Don't clutter. Not clutter all these things. Old logs. Oh, we can't track this. How inconvenient that is. Okay. Oh, okay. Like dragging around. Okay, let's put these logs into No, I can't drag this again. Oh no. Why am I even doing this? Okay, now that's a little bit cleaner. Still few logs lying around. Yeah, okay, that's very clean now. We don't have a lot of things going on here. Okay. So I think this is gonna work, hopefully. Run agent. One main 6. Oh, how did they get the main 6 name? I'm curious. Let's run it for one iteration and see if it works. This is the TS file, so I just shoot myself in the foot by writing a TS file instead of a JS file. My God, where is package.json? Maybe we can do something interesting here. Like run interpreter. We're gonna run compile, and then we're gonna run dist slash interpreter.js. I guess. Let's see if it works. I don't think it's gonna work, but yeah, it doesn't work. Replay main.json. No such file. I think I do have a script to kind of run the TypeScript commands directly. Let me steal from my old thing. So this is the script that I have been using to run the TypeScript commands. So let's see if this works. I don't think we need the max old space. Okay, let's see. Okay, still cannot find replay main 0. Oh, list. Okay, it's running list. Oh my God. That's interesting. Okay, no wonder. Okay, it's failed. Process results on close. Wait, what? Where's code 0? How? Spawn, run, environment, fleet, spawn. How did it exit 0? Nothing. Okay, there must be something wrong here, right? Let's see what went wrong. kaggle-environments run. Maybe I need to put a run here instead of here. It doesn't work like that, right? Okay. Oh, wait, I think I need to do the virtual env thing, right? Oh yeah, that's gonna make things a lot more complicated if I need to do the virtual env thing. I shouldn't need to, right? Child process should actually inherent replay. Could not find. Oh, okay. Now, why did it exit with code 0? That's weird. Could not find main. Could not find main. Could not find main. This is something interesting. I think it's a current directory thingy. Spawn directory. Okay. So find the working directory. Okay. Directory name. Okay. Let's see if this works. Still could not find, huh? Maybe I can do something like this. directory name plus. Can I resolve the directory? Absolute path from relative. You can't. Not supposed to between inst an instant. What the hell is this? Build agent. What is going on here? What is going on here? Okay, this is proving to be a little bit trickier than I thought it would. Somehow cannot find the file. I think I shouldn't do it in the absolute directory because it's gonna screw up more things. I think we can work on resolving this problem. I want to set the working directory. But I think I need to do this instead of the other one. Let's see if this fixes the directory thingy. Oh, it still doesn't work. Could not find. So why was I able to find previously when I run it from package.json? Why was this able to find? Still failed. Let's actually open this file and see what went wrong. Maybe this is a simpler problem to solve. I don't know. Two, 5, 4. Return action run. Not supported instant action handler. Ah. Okay. 116. If OS pass exists raw. Let's print out something here. This does exist, right? I'm pretty sure this exists. This definitely exists. What? Why does it think that it doesn't exist? This is weird. False. Oh wait, it's printing out multiple of them. It's printing out multiple of them. Okay, maybe that's why it didn't. Oh no, I forgot the spread operator here. Oh my god, that's such a stupid mistake. I forgot to spread it. Oh my god, to spread it out. Oh no, I spent so much time wasted on this stupid bug. Okay, now I'm pretty confident that it's gonna work. Okay, let's remove that. Yeah, now it's working. Okay, good, 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 good. Okay, then the previous solution would actually also work, right? Yeah, nice. Win 0, top to 0. I guess that makes sense. That actually makes sense. Oh no. Okay. Okay. Let's undo all the previous things that we did. I think we just missed out on the spread operator. As I mean, sometimes it happens. Sometimes it does happen. Let's undo all of that. Back this spread operator. Or I think I want to print some stuff. In the process script, we should also pad this one. Pad this as well. Main 0 complete. Okay. All process exit with code 0. Okay, I don't think we need to print that. Let's try to run it again. So the main is not winning. That's a little bit strange because I would expect it to win actually, not lose. It should win against this for sure. Oh wait, it's playing against itself. Okay, that's why it didn't win. Let's take a look at the results. Oh no, this is. Oh, it's outputting this thing. Oh, wait a second. Why is it outputting this thing? No, I didn't want to. I didn't want it to output that thing. Maybe I need to change it to evaluate. Yeah, maybe I need to change it to evaluate instead of run. I want to get the simpler output, not the complicated output that we don't actually need, right? So So this one is gonna give us a simple output. Nice, nice. It went we want, right? Yeah, looks pretty good. I think we got our interpreter here. I just need to print out the reward. Just need to print out the reward. So how do we want to structure this? Because we want to play one by one, right? So okay, we'll play it one by one. So that means we should only get one result each time. Okay. I don't think there's a choice. There's a chance that we evaluate more than one, right? Because that's not what we want at all. Yeah. So you know what? We'll just do that one, and we'll write a separate function to compile result. This one will just take in the results. And this one is gonna just give us the results. So this one is gonna process the result. It doesn't need the agent actually, and then we're gonna compile results. Result equals process result 0. Results dot push result. And then we'll compile result outside. Process result. Compile result. I think we also want to print the reward, right? Okay. Let's run it for five episodes. Wait, what? It's running in parallel. Oh, actually, it's running in parallel. Oh my god. It's actually running in parallel. God. Oh yeah, nice. That's an unintended consequence of doing it this way. We're actually running in parallel. We're actually running in parallel. Ah. That's so interesting. We got a parallel running for free. Oh my god, that's so funny. That is actually so hilarious. That is hilarious. Okay. Mm-hmm. I hope it's thread safe. I hope it's thread safe. Mm. Okay, I guess that doesn't make sense now. Let's do this. Nice. Now we're utilizing the full power of our CPUs. Let's show the CPU usage. You can see there's multiple Pythons running in parallel and multiple nodes running in parallel as well. So we're utilizing the M1 chip to its fullest. Reward undefined. That's a little bit strange. Oh yeah. Oh okay. It should be 0, not okay. Okay, it's okay. Let's run it again. Okay, this is actually much better than our previous evaluation script, so I might switch to this even for the evaluation because it can run in parallel. Oh my god, we're cheating a little bit here, I think. Um, mhm. Okay. Okay, I think we have actually accomplished our goal to write an interpreter. Now I think we just need to Yeah. I almost feel like we should run them in series. Right. Like I don't want to run them parallel because it's gonna stuck each other or something like that. It's gonna spawn too many things. So I feel like we should run them in series. If I want to run two of them. So let's add a callback here. Let's add a callback here. Hmm. Okay. 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 So now we have this set up already. We can do some modifications, right? So I think the first I want to try this interpreter if it can help us achieve a better workflow in terms of trying out these optimizations. So one thing I want to try is if we don't mine with 3 ships, is it actually better? That's the hypothesis. I don't know whether it's gonna be better if we don't mine with 3 ships. So I mean that's the first thing I'm gonna try to run. So here's what I'm gonna do. I'm gonna run like five of main here, and then we're gonna pass in a thing that console logs done, right? So this one actually we're gonna run main 10. So we're gonna name our previous agent main 10, right? So the previous agent is actually the one we submitted yesterday is doing super well. It's 1264 is actually the highest we've gotten so far, right? And we're back to the top 3. So I'm gonna name this 10, right? Let's actually name it here. This is main 10. Okay, and then we will copy this one, main 10, and it's gonna take list 10, bot 10, right? So and then we also need to copy the current bot and rename it to bot 10. And then we're gonna run a compile to get the file of bot 10. So now we should have the bot 10 here, right? Which is good. And then we're gonna copy this and rename it to this 10 so that our bot 10 stays here. And then our main 10 is able to find the bot 10. Yeah, okay. What is going on here? Wait, what? Cannot redeclare the variable. Oh, interpreter D. Oh, that's a bug that I think I've seen before. Let's just remove these three files. Okay. I don't know what happened with the TypeScript stuff, but it's not. It doesn't like it. Okay, so so this should give us a comparison between the maintain and the current bot. Let's run it to see if it works. I hope we don't fry our CPU because of this. This setup also allows us to run the machine learning algorithms. Okay, so the maintain didn't work. The maintain didn't work at all. I don't know why it didn't work. Main one is working. It's actually null. Where is the outplay? Wait, what? Out log. Oh, it's not printing out logs because it's evaluation mode. Okay, I see why. Dist 10 slash bot 10 dot js. Honestly, I don't see anything wrong with this. Okay, let's just try to run manually to see what actually happened here. Oh no. Okay, let's change it here. It's fine. Need to remember to change it back. And it just disappears. It's not a constructor. Let's see if this works. And if this works, then maybe I have a solution. I don't want them to interfere with it. Okay, this also doesn't work. Why does it not work? That's so weird. I did a recompile. Still doesn't work. Core IO is not a constructor. Core IO is not a constructor. Core IO. If I run it directly, will it work? This is a little bit weird. What is the difference between bottom and bot? There should be no difference. It should be the same. Should be no difference. Okay, let's try the last result. Let's delete this and then make a copy. Button. Make sure that this one is pointing to button. Then I don't know why it didn't work. Let's see. I think it's gonna give us the same error, but I have no idea why it doesn't work. Could it be the circular dependency that I accidentally introduced and causing it to fail? Could be, could be. Actually, I have a simpler way to deal with this. Let's just name it this 10 and bot. Right, I think that would solve the problem for us. Let's just remove button and use the bot. npm run compile. Now we have a bot. I think it's a circular dependency that I introduced. So I actually shouldn't have done that, but whatever. I just take the fastest way to get through things. So this is gonna be our distance, and we're gonna use this bot inside here as the bot. Right, so it's not gonna care about all these other bots. Let's delete all the other bots. And also delete interpreter. And test. I think those things mess up a lot of things. And then we just treat this as the main 10, right? I think that makes sense. Does that make sense? I think it makes sense. Now let's run this, and it should give us some output. And make sure our main 10 is pointing to the this 10, not something else. Okay, it works. It works. Let's revert this change and run our interpreter. the interpreter is gonna run main 10 as a baseline, and then it's gonna run new main to compare the performance. While we're waiting, let's check out some stuff. 1264. Okay, it's actually getting better and better. Our score is actually improving, huh? Oh, we actually beat the first top player. Wow. That must be so lucky for us to be the top player. I feel like I've never beaten him before. Let's go and watch this one. I'm quite curious on why we beat him. Maybe we got super lucky somehow. We're farming pretty well at this stage, so let's look at the ship count. We're not the last, we're also not the top. So this guy's farming is clearly much more efficient than everybody else. So that's something I want to improve on. And where did we get lucky? Okay, so he put first shipyard, and then we immediately put. Who put? Actually, the blue puts the first shipyard, and I think we had the same logic to put shipyard once once someone else put the shipyard. So we immediately put two shipyards, and he also immediately put two shipyards, and we put actually even more shipyards. That's crazy. We put so many shipyards in consecutively. I think this gave us a huge advantage later. Once we are able to, defend these shipyards, I think it's just won for us. Yeah. So, wow, I'm so surprised we won. Oh my god, that's crazy. This strategy actually works. It's not intended to work so well, I think, but somehow it did work. So I'm not complaining. Okay, let's see. So main 10 is getting decent reward, and main is also getting decent. I mean, that's fair, right? Because we haven't changed anything. So I think next up, I'm gonna try our optimization, which is the don't mine with three ships. I feel like our mining is not optimized. So one thing that the top players do is they don't mine with three ships. Right? We're the only one who is mining with three ships. So that's something we're gonna try. For now, I'm gonna take a short break. I'll be back in about 10 minutes. So see you in 10 minutes, about there. Okay, let's write our improvements to the agent and see if it outperforms our baseline. So the first thing is we're gonna change this 5 to 10 to run 10 evaluations. Oh wait, but if you run 10 in parallel, I don't know if my computer is able to handle it. We will see. I think there's gonna be a lot of live logs and interrupting each other. Potentially running out of memory as well. Oh, okay. Actually, Google Chrome is using a lot of so many electrons here. I guess that's the Streamlabs. Okay. Memory pressure, memory use is already 13 gigs. Okay, that's quite a lot. Actually, quite a lot of memory. Okay, maybe we need to close the Chrome so that we get back a little bit more memory. Okay, actually, we can check the memory up here. I think we have the memory stats here. So we have 5 gigs of memory. Let's close some of the stuff that are not necessary so that we get back some memory and CPU for our evaluation. Let's close all this that we don't need right now. See if we get back some memory. Okay, the streaming software is taking up a lot of memory. Yes, that's unavoidable. Okay, so let's. I think this is fine for now. Oh, let's write our changes. Very excited to see whether this thing works. Yeah. Okay, so there's a lot of replay stuff here, which is clogging up our space a little bit. You know what? Let's clean up this thing a little bit first. I feel like I don't want to deal with too many files here. It's clogging up space. Let's put them all into the replay folder. So that they're less of annoyance. We'll do this, and let's see if it works. /file name. A replay, and then we don't need this anymore. Yeah, let's see if this works. Memory is actually doing fine. It's not taking up a lot of memory. Yeah, it's not taking up a lot of memory. It's mainly the CPU. Okay, I think it works. Yeah, it works. So okay, if this works, then we could just delete all the old ones so that it's less cluttered. We can also put the old replace to the correct place. So that they take up less space. All right. Okay. I think that's fine. Now this is fine. Okay. Okay, it's fine. Let's see. Do we want to compete with the attacker as well? Not too sure. Yeah, we can run the other evaluation, I guess, if that makes sense for the attacker. Right? So, is this enough? Is this enough? What about the previous evaluation scripts? Compile result. And evaluation scripts. Okay. Attacker, this one, and the old one. I think we don't need this anymore, right? Also, I don't think we need this anymore. We just need to evaluate against attacker. So this is no longer needed. Let's run. Actually, why doesn't kaggle-environment evaluate running parallel? That's a little bit strange, right? It should support running in parallel. Oh, nobody mentioned this. That's interesting. Okay, never mind, it's fine. We'll run the evaluation to make sure that it still works. Let's reduce it to 5. Don't need so many. The interpreter is gonna compare our performance against the previous baseline, and the evaluation is gonna compare our performance against the attacker. So it's kind of slightly different evaluation matrix. Let's not worry about kaggle stuff yet. It's super slow though. Pretty happy that we already finished the interpreter. I thought it's gonna take longer time, but turns out it's not that hard if we leverage the kaggle env CLI. There's actually also a HTTP server mode, but I think that's not really required at this stage. Okay, it's taking a while to run this evaluation. Okay. Okay. It didn't actually win against this two, which is a little bit surprising. A little bit surprising. Okay, I think it's fair. It's fair. You can change it back to 10 for the official one. Okay, okay, now we're done with all those random things. Let's focus on what we are here for. We want to optimize the mining strategy. So what we're gonna do is, oh, mine small strategy is already here. Wait, is mine small actually somewhere else as well? P mine small, right? So there is a P mine small as well. Let's remove that. I think that's unnecessary, obviously. And then we're gonna remove the mine small strategy from everywhere. Yeah, so that's our premise that this is gonna do better than the old baseline, right? So let's test this out with the interpreter. It's gonna go crazy. Yeah, it's gonna go crazy like this. The stream might even start to lag, right? CPU load is going 100%. I feel like we almost should have batched it. Okay, so this is the old reward. We won 4 out of 10. Oh my god, I can hear the fan. This is the first time I'm seeing fan. I'm hearing the fan. Actually. Oh my god, I think the stream is actually lagging. I can see myself lagging already. Yeah. Alright, it's actually causing my stream to be lagging. That's so funny. Okay, I think it's safe to say that this optimization works because now we're winning 7 out of 10 instead of 4 out of 10, so it's definitely worth it. Right, so let's see, how do we do this? Let's not run them like that, right? So And the first thing we need to do is make them async. And then we're gonna do sleep, right? So how do we do the sleep here? I guess we just await sleep. We sleep about how much should we sleep for? It takes about 20 seconds to finish each game. So let's split about 15 seconds. I think that should help us deal with the CPU usage. Let's run it again. Observe the CPU usage. This is a very rudimental way of dealing with concurrent parallel processes. So it's spawn 1. It's gonna wait for 15 seconds until it spawns the next one. I think this is fine. And I think 50 seconds is actually too conservative. Yeah, 15 seconds is too conservative. But it's not printing out stuff. What? It's not printing out the reward stuff. And now it's printing out reward. Oh, it's so slow. Okay, that's gonna be something wrong, right? This is definitely not what I expected it to be. Maybe let's sleep for 10 seconds. 2, 3, 4, 5, 6, 7, 8, 9, 10. Start another Python. Okay, correct. But this is more correct, I feel. So at any point in time, there's about 1 to 2 Python processes running. It's not, I feel like we can afford to be a little bit more aggressive because the CPU usage is still quite low. Yeah, can definitely afford to be a little bit more aggressive. Maybe 8. 8 is probably okay. See how many, is it gonna cost a lot of processors to stack up together? Now there are 2. 3. 2. 3. Still 3. Still 3. Still 3. Okay, so it's like about 3 running in parallel, which is fine, right? Which is actually fine. feel like we could afford to be a little bit more aggressive, but I think this is pretty fine. And the stream is not really lagging, right? So yeah, that's pretty good. That's pretty good. I think this is a fine balance. Running it concurrently. And my CPU fan is, my MacBook fan is kicking in. I'm glad I bought the MacBook Pro, not MacBook Air. Otherwise, our computer is gonna suffer quite a bit with this load. Yeah, so the main 10 actually won 7 out of 10. That's a little bit scary. Not gonna lie, that's a little bit scary. So it wasn't supposed to win that many rounds. It's gonna like outperform our new baseline, I feel like. Oh no, please. That means I need to do something else. Maybe it's just noise, you know, too much noise. But now we have this interpreter set up. We can actually use this reward to train, you know, deep learning models, right? So that's pretty cool. You know, now we have one iteration equal to one complete round of game. Not ideal, but it could work. It could work. Yeah, so I think I'll do it maybe tomorrow or something like that to try out the deep learning algorithms. For today, we're just gonna, you know, finish up the interpreter, maybe you know, improve the mining efficiency here, and we'll just call it a day. I think it's pretty good progress overall. Okay, nice. We beat the baseline, right? So here you can see we won 8 out of 10, and we're top 2 all the time. The previous baseline was only 7 out of 10, and it's top 2 9 out of 10 times. Right, so I think it's pretty safe to say that we beat the baseline. All right, so I think we don't need to track the dist file. Let's add that to our ignore. Maintain, okay. Okay, so this is gonna be don't mine with 3 shapes. Okay, cool. Cool. So I'm pretty sure that this one is gonna do well on the leaderboard. Just for the completeness sake, I think I'm gonna run an eval 3 on this agent as well, just to be extra safe that we're not doing something wrong. Oh no, it's not outputting to the correct folder. Okay, let's fix that. Okay, now it should be correct. Let's run the eval 3. So we run three rounds of 3 episodes and see if it beats the attackers, both when it's near and far. So this will give us a baseline to compare with when there is an attacker. We should theoretically win all 6 games. Let's hope that this is indeed the case. Let's see, I think it should finish pretty fast if you're beating them. If you're not beating them, then it's gonna take a while. Oh no, something went wrong. Oh, okay. No, okay, that's my bad. That's my bad. I typed this wrongly. // Let's try to run it again. Hopefully it didn't create random files. It didn't. Meanwhile, let's meanwhile let's package this. Prepare for submission. Is that the only change we made? Yeah, I think that's the. Oh no, we actually didn't win one. I guess that's fine. That's pretty fine for me. Maintain don't wait. Maintain don't build threshold to attack. Defend over attack. Okay. Okay, I guess we have one more change. Defend over attack. Yeah, maybe we added this change as well. I forgot why we did that. Anyway. Defend over attack, don't mind with 3 ships. So let's submit this. Hopefully it's gonna get close or overtake the top 2. I hope. Okay, submitted. Yeah, the top 2 is like getting ridiculously higher. So it's like almost one. It's actually more than 100 scores better than ours, and we're only like 30 higher than the next. And then there's a lot of people stuck around this range. Stuck here. Cannot get to 1200. Alright, I think that is everything I want to do for this stream. So we finished the interpreter. That is really nice, and it's actually parallel. And I managed to, make an improvement, make a very small improvement on mining efficiency. We didn't even run like a replay, right? We didn't even run the replay to see how it works. Maybe we should actually run a replay to see how it works, just to make sure we're not doing something very stupid. Yeah. Feels wrong to not watch a replay. So let's actually watch a replay. Okay, this one took a while to finish. We didn't. Yeah, we won, but we didn't like completely dominate the game. So we're not sending 3 ships. Which, let's see whether we're doing better. We're actually doing not too bad. I think we have more core and cargo than some other players. And here we're not doing too bad as well. By here we're behind red. We're a little bit behind red, but we have a lot more shipyards. So yeah, here we are already above red. Right? We have a lot more shipyard than red, and by this time we're already dominating. The only problem was red, so yeah, I think we couldn't overtake the red, and I guess we went into the peaceful ending mode eventually. The purple went into the peaceful ending mode pretty early, I think. That's why it's actually was able to mine a lot of cores. But I think we will outmine him quite easily because we just have more ships. Actually, his side has more core than us. So if it went a bit longer, then it might change. Anyway, it's pretty good that we're getting to here. Alright, I think that's the end of today's stream. Hope everyone enjoyed this process. I will see you in the next stream. Maybe today, later, or tomorrow. I don't know for sure.